Lewis acid-base theory. In this period we discuss Lewis acid-base theory. G.N. Lewis in 1923 proposed a more generalized theory to explain the nature of acid and base on the basis of electron theory of valency. The basis of electron theory of valency. This is widely accepted theory because of its simplicity. This theory was proposed by Lewis in 1923. It is more generalized theory to explain the nature of acid and base on the basis of electron theory of valency. This is widely accepted theory because of its simplicity. After end of this period, you would be able to understanding the Lewis theory of acid and base, understanding the Lewis theory of acid and base. Lewis theory. Lewis acid is a substance which can accept a pair of electrons. Lewis acid, a substance that can accept an electron pair to form coordinate covalent bond is called Lewis acid. What is Lewis acid? A substance that can accept an electron pair to form coordinate covalent bond is called Lewis acid. Lewis acid, substance which can accept a pair of electrons. Lewis base, a substance that can donate pair of electrons to form coordinate covalent bond with acid is called Lewis base. Lewis base is substance which can donate a pair of electrons to form coordinate covalent bond with acid is called base. Lewis base is substance that can donate a pair of electrons. Lewis acid. Lewis acid is an electron pair acceptor or electrophilic. Lewis acid, which is electron pair acceptor, is called Lewis acid. Like boron trifluoride, aluminum trichloride, zinc chloride, H plus FeCl3, so on. These all are Lewis acids, which is accept pair of electrons from another substance to form a coordinate covalent bond is called Lewis acid. Lewis base is an electron pair donor. Electron pair donor is also called Lewis base. This is also nucleophilic, a substance that can donate pair of electrons to form coordinate covalent bond with acid is called base. Simply we call electron pair donor is called Lewis base. Like example, hydroxyl ion OH minus, cyanide ion Cn minus, H2O, NH3, so on. These all are Lewis bases. Lewis acid and Lewis base. Lewis Neutralization reaction. Formation of coordinate covalent bond between acid and base is called neutralization. Formation of coordinate covalent bond between acid and base is called neutralization. Formation of coordinate covalent bond between acid and base in ammonia and boron trifluoride. Ammonia and boron trifluoride. Ammonia contains one lone pair of electrons on central atom of nitrogen atom. Ammonia NH3. NH3. It presents one lone pair of electron on central atom of nitrogen atom, and boron trifluoride is electron deficient molecule. Boron trifluoride is electron deficient molecule. It presents empty orbital on central atom of boron. Ammonia donate one lone pair to boron trifluoride. Ammonia donate one lone pair to boron trifluoride to form coordinate covalent bond between ammonia and boron trifluoride. This bond is called Lewis bond. Ammonia central atom present one lone pair of electrons. Boron trifluoride present empty orbital. In this reaction, boron trifluoride pair of electron acceptor. So this is Lewis acid. Ammonia in this reaction pair of electron donor. So in this reaction ammonia Lewis base. Lewis acid, Lewis base. Ammonia and boron trifluoride to form ammonia boron trifluoride bond between by the transfer of pair of electrons from ammonia to boron trifluoride. One is electron pair donor, base electron pair acceptor of boron trifluoride, acid. Ammonia and boron trifluoride. These two electrons transfer from base to acid, then form two electrons bond between ammonia and boron trifluoride. This is also two electron bond, coordinate bond, but this coordinate bond formed by ammonia to boron trifluoride involving two electrons given by one of the substance in this reaction. Formation of coordinate covalent bond in ammonium ion. Ammonium ion. Ammonia. We discuss it present central atom one pair of electrons and hydrogen ion present one empty orbital in its valency shell. These hydrogen ion act as ammonia contains one lone pair on central atom and hydrogen ion is electron deficient molecule. That means one empty orbital in its central atom. Ammonia donate one lone pair to hydrogen ion to form ammonium ion. In this reaction, hydrogen ion pair of electrons acceptor, so it is act as Lewis acid. Ammonia pair of electrons donor in this reaction, this Lewis base. These two electrons transfer from ammonia to H plus ion, then form a new bond between ammonia and hydrogen ion, then form ammonium ion. Ammonia Lewis base, hydrogen ion Lewis acid. Boron trifluoride and fluoride ion F minus. Boron trifluoride present one empty orbital in its central atom of boron. Fluoride ion contains one lone pair of electrons on fluoride ion. Boron trifluoride act as Lewis acid. Fluoride ion act as Lewis base. This pair of electrons transfer from fluoride ion to boron trifluoride to form a new bond between boron trifluoride and fluoride ion. Boron electronic configuration 1s2, 2s2, 2p1. Fluoride electronic configuration 1s2, 2s2, 2p5. These two electrons transfer from fluoride ion to boron. The following specification can be act as Lewis acids. Molecule in which the central atom has incomplete octet. Incomplete octet molecules all are Lewis acids. Like example, boron trichloride, boron trifluoride, aluminum trichloride, magnesium chloride, beryllium chloride, ferric chloride. These all are molecule in which the central atom has incomplete octet. Compound in which central atom has incomplete octet means electron deficient molecules. Electron deficient molecules all are Lewis acids. Less than 8 electrons on central atom of molecule is called electron deficient molecule. Simple cations all are Lewis acids. Like example, H plus, Na plus, K plus, Ca plus 2, Ag plus, Cu plus 2, Fe plus 3. These all are cations. These cations act as Lewis acids. Have very little tendency to accept electrons. Cations like H plus, Ag plus have greater tendency to accept electrons. Greater tendency to accept electrons. Molecule in which central atom has empty d orbitals. The compound in which central atom has available d orbitals and can accept their octet. Like example, silica tetrahalide, germanium tetrahalide, tin tetrahalide, phosphorus trihalide, sulfur tetrafluoride, sulfur silicon tetrafluoride, tin tetrachloride. These all are empty orbitals available on central atom. Molecule having a multiple bond between atoms of dissimilar electronegativity. Molecule having multiple bond between atom of dissimilar electronegativity. like CO2, SO2, NO2, SO3. These all are multiple bond between dissimilar atoms act as Lewis acids. CO2. C double bond O react with negative ions then form COOH. COOH. Lewis acid. Lewis base. Pair of electron donor. Pair of electron acceptor. Types of Lewis bases. Lewis acids like all cations are Lewis acid. Compound which contains incomplete octet, that is electron deficient molecules. Compound with central atom having available d orbitals like silicon tetrafluoride. Molecule containing double bond between dissimilar molecule atoms, CO2, SO2, so on. Element with electron sextet. These are acids. Oxygen, sulfur, selenium, tellurium, these all are acids. These acids. Element which contains 8 electrons. Carbonium ions, CH3 plus, C2H5 plus, this is also act as acids. Lewis bases. All anions are Lewis bases, like example Cl minus, F minus, OH minus, Cl minus, O minus 2, SO4 minus 2, NH2 minus 2. These all are Lewis bases. Molecule containing one or more ion pair of electrons. Central atom present one lone pair of electron molecules act as Lewis bases. Like H2O, NH3, EH3, ROH or NH2. Molecule having multiple bond between carbon atoms like C2H4, C2H2, C3H6. These are Lewis bases. All negative ions, that is anions, Cl minus, F minus, OH minus, Cl minus, O minus 2, SO4 minus 2. Molecule containing one or more lone pair of electrons, H2O, NH3, EH3, ROH, RNH2, ROR. These all are pair of electrons on central atom. Molecule having multiple bond between carbon atom, C2H4, C2H2, C3H6. Limitations of Lewis theory. This theory failed to explain strength of acid and base. This theory explains strength of acid and base. Strength of acid and base. This theory failed to explain strength of acid and base. That is strong acid, strong base, weak acid, weak base. Does not explain about this theory. Acid-base reactions are very fast reactions, but Lewis acid-base reactions are very slow reactions. If we were to explain neutralization reaction. Neutralization reaction fail to explain. HCl H2SO4 cannot form coordinate covalent bond according to this theory. This theory could not explain strength of acid and base, that is strong, weak acid, strong base, weak base. All neutralization reactions do not involve formation of coordinate covalent bond. NH3 boron trifluoride. These form coordinate covalent bond, but HCl plus NaOH does not form coordinate covalent bond. Acid-base reaction very fast, but formation of coordinate covalent bond is slow reaction. We could not explain catalyst stability of H plus ions. H plus ion act as a catalyst that nature cannot explain. Lewis theory states that acids are electron pair acceptor, base are electron pair donor. Acid and base. Lewis acid and base form coordinate covalent bond. Cations are Lewis acids, anions are Lewis base. Cations are Lewis acid, anions are Lewis base. These acid base theory explain about which is formed by coordinate covalent bond between by the transfer of pair of electrons from one substance to the another substance to form a coordinate covalent bond. Lewis theory states that acids are electron pair acceptor and bases are electron pair donor. Lewis acid and base form coordinate covalent bond. Cations are Lewis acid, anions are Lewis bases. Which is Lewis acid? What is Lewis acid? Electron pair acceptor NH3, H2O, CH3, boron trifluoride. In these four compounds, boron trifluoride present on central atom of empty orbital. These molecules have electron deficient molecule. These central atom present less than 8 electrons. So these boron trifluoride accept pair of electrons from another substance. So this boron trifluoride act as Lewis acid. Correct answer is boron trifluoride. What is Lewis base? Lewis base. Boron trifluoride, ammonia, boron trifluoride, hydrochloric acid. Lewis base. Pair of electrons donate to another substance is called Lewis base. Boron trifluoride electron deficient molecule. This is pair of electron acceptor. So this boron trifluoride substance acts as Lewis acid. Ammonia. On central atom of nitrogen present pair of electrons. These pair of electrons donate to another substance. Then ammonia acts as Lewis base. Boron trichloride also Lewis acid, HCl Arrhenius acid. So Lewis base ammonia NH3. Correct answer is B. Which ion is Lewis acid? All cations are Lewis acids. Cl minus, Mg plus 2, O minus 2, HCl. Cations are Lewis acid. Mg plus 2. Cl minus anion, O minus 2 anion, no charge on HCl, then positive charged particle of Mg plus 2 Lewis acid. Correct answer B. Frequently asked questions. State and explain Lewis theory of acids and bases. All Lewis bases are Bronsted-Lowry bases. Explain with an example. All Lewis bases are Bronsted-Lowry bases. What is Bronsted-Lowry base? Proton acceptor is called Bronsted-Lowry base. A Lewis acid need not be a Bronsted-Lowry acid. Justify this statement with an example. Bronsted-Lowry acid, proton donate to another substance is called Bronsted-Lowry acid. Classify the solvent as per Bronsted-Lowry theory. Bronsted-Lowry theory solvents as per theory. To explain about Bronsted-Lowry acid-base theory, some of the compounds act as acid and bases. Depends on transfer of protons. So this Bronsted-Lowry theory is called proton theory. Thank you once again.